Well, it's time to overcomplicate another project and then muddle my way through it. If you've been following the channel for the past few months, you'll know that I'm working on rebuilding a 1956 Jeep CJ5 that I pulled out of a friend's woods. And for reasons that I went over in the last video, I've chosen to rebuild the body rather than buying a new one. Since Fred and Barney said that they weren't really interested in the Jeep, the next thing I want to do is make some new floor pans. And to do that, I want to make a sheet metal brake. Now, I've kind of fallen down a rabbit hole on this one. I started looking at what's out there for commercially available ones and ones that other people have made, and I came across electromagnetic sheet metal brakes. And I said, that's what I want. The problem is they cost about $3,000, which would be enough to just buy the new body for the Jeep anyway. So here we are, I'm going to try to make my own. Of course, in trying to figure out how to do that, I realized I was way in over my head, and did what I usually do, which is ask for help on Discord. And in doing so, Dan said, why don't you look at using microwave oven transformers? And it turns out he had 8 of them that he was willing to send me. So Dan, thanks for that. Now, if you know anything about these or have seen videos with people using them, the first thing you learn about them is they're capable of producing really dangerous levels of voltage. But I'm not going to use them that way. The other thing to know about them is if you choose to harvest them out of a microwave, do your homework, do it safely, or just do what I did and, safest way, have someone else do it for you. So, one of the other things I should mention is Craig from Craig's Workshop sent me a website that has basically all of the instructions on how to build an electromagnetic sheet metal brake from scratch in really an amazing amount of detail. But since I have these, I'm going to try to use them. I don't understand a lot of the equations behind electromagnets, so I'm going to kind of work through this empirically rather than trying to do the math on it. One of the things I do understand is the strength of the magnet is a function of the number of turns of wire times the amperage. So you can either do more turns and fewer amps, or more amps and fewer turns. These transformers have 2 windings, primary and secondary. This one has fewer turns but heavier wire. This one has more turns but a lot thinner wire. The videos I've seen on YouTube of people turning these into electromagnets, they're always using the primary and higher amperage. Since this one's missing the secondary anyway, I'm going to start with that one. No harm in cutting this up first and seeing how it works. These things are made out of 2 stacks of laminated pieces, an E and an I, and it's just welded right along there. Now what we have is an open magnet where the magnetic field will come out the top, go back into the sides. With this on here, it just went through there, so that's why you need to take that off. I'll cut this down shorter when I'm ready to put it all together. So one of the things I didn't understand about this is if this is essentially a resistive load or how much inductive loading there was on it. Turns out it's mostly resistive load. So I kind of ran afoul of Ohm's law. I had to pick up this little power supply, but now I can turn this up, and we've got a magnet, and a pretty strong one. I do want to go through and figure out what the resistance of this is, and just how much it's loading, so I'm just going to dial in 1 amp increments. So even though this wire is rated for 6 amps continuous, at 10 amps, even after a few minutes it's not heating up a whole lot. So I feel pretty good with pushing 10 amps through, might even be able to go more, but that's all this power supply does. So plotting those numbers against each other, pretty good linear relationship with a 0.39x, so 0.39 ohms resistance in that, which is nice to know moving forward. On some of these, the laminations did come apart a little bit, but I don't think that should make too much of a difference. For the housing, I picked up this 5-inch square tube from the drop section at the local steel supplier. and then split it in half with the torch. Did a little rough cleanup on the mill. It's probably not the most efficient use of material, but gave me something that was the right size and shape for what I need. And then I drilled and tapped some holes for later use. I need to temporarily seal up all the bolt holes, so I'm just using some hot glue for that. I also got some little thermal switches, and I'm just putting one on each magnet so I can have it cut off if it overheats. And all the wires get sealed off with hot glue too. I'm using basically the cheapest epoxy I could find. It's a slow hardener, but it's not a casting resin, so I'm going to do this in pretty thin layers. Now that first epoxy pour is set up, I want to make sure I've got good continuity between everything before I encase all the connections. And make sure there are no shorts. I tried a few different ways of cutting off the tops of the magnets, but since I have to mill it flat anyway, the best one seemed to be to just tear through it with an old end mill. Since this thing's about 3 times the length of the travel on my mill, it requires multiple setups, and some indicating and shimming on each one since none of it is straight. I'm doing a light coat of polyurethane on here. It's mostly aesthetic, lets you kind of see down in there a little bit more, and if this thing doesn't work out, it makes it a good start for some sort of hipster coffee table or something. So I was thinking this part of the video I would do some self-deprecating jokes about not being able to plan ahead. Then I saw a video where Adam Savage was talking about if you're doing a complicated project and you're a little overwhelmed by it, you just kind of do the first step you know that you need to do and then figure the next step out when you get there. I knew I needed to make a big magnet, so I did that. I also knew I needed to put some hinges on, so I drilled and tapped some holes in the end to mount some sort of hinge that now is the time to figure out what that looks like. I spent way too long in CAD drawing up a variety of hinges that would mount here that I didn't really like. So I went back to the website that has the instructions for the MagnaBand and made these based on that, thinking, I would make a piece that mounts here, mounted in that. The more I looked at it, the less I liked that. Figured I could probably mount it here, so I made a little piece for that, could notch that out. Then I realized this is way too thick here. This is going to be my clamping bar, and this would stick out way past that. And what that means is if you're doing like a Z-bend, that's going to limit how tight of a bend you can do. I was thinking beef these up a little bit. Turns out I should just go back and read the instructions and do them according to that. The hinges are turned from 2 pieces of bar stock sandwiched together. I super glued them together before I took them to final size just to hold them together a little bit better. I should probably also mention here that the idea with these hinges is to keep the ends of the machine completely open so you can hang things off the ends. Since I can't pass this through my 4-jaw chuck to hold it together, once I milled it to final size I also put a cap screw through the middle, and then I center drilled the ends just to make the setup in the lathe a little bit easier. Turning an interrupted cut like this into a deep groove presents a bit of a challenge. But I just kind of nibbled away at it with different tools, working one way and then the other. And then once I got it all done, flipped it around and did another one on the other end. This tapping head was a gift from one of my patrons. It's really the first project I've used it on, and it is pretty much life-changing. The other piece of the hinge gets done pretty much the same way, but this time I decided to rough out a lot of it on the mill first. Made for a lot less severe interrupted cut. Because the grooves are narrower on this one, I did most of it with just a flat bottom grooving tool. Plunge in and then feed along once I get to depth. The drilling got a little bit off center. Either my center wasn't quite right, or it was because it was drilling down between two pieces of material, but I just trued it up real quick with the boring bar. So, after a bit of deburring on these, and a quick test fit, I realized these holes are at the wrong angle. Well, it's the right angle, it's just the wrong reference. It's 30 degrees from here rather than from here. So as you can see, that doesn't even go to 90. So, let's see if I can get myself out of this one. I've got my angle reset to 30 degrees the other way. I've got a screw threaded up through the bottom just to keep this screw head from rotating. A little deburring and clean up with a file, and if you're surprised that worked out, it kind of makes two of us. I think that'll be okay. These screws end up getting Loctited in and filed off, so it's not like they're coming in and out a lot. I don't really like doing fixes like that, but even less I like starting something like this over because, quite frankly, these things have been kicking my butt. I've had way too many false starts and screw-ups trying to figure out just how to machine these, get them done. I'm not going to go into that because I don't really want this to be a 5-part video of all of my mistakes. Let's just say I want to get these done and move on. The final piece of the hinges is the little curved washers, and I'm just using an old nut to make those. The last thing the hinges need is just to have the bottom corners rounded over for clearance. So now I've got smaller hinges, but I got 4 of them instead of 2. Should be pretty good. If I try to drill this hole with the drill bit, it's going to hit the metal and it's going to deflect. So I think I'm going to just plunge it with an end mill. As a little bit of a sanity check, I put some transfer screws in the hinge. Made sure I had those little marks there and drilling on the marks. I got the second pocket cut in here, and I just filed the corners of these off so it would fit in the back corners there. Unfortunately, to do these other two, I can't hang it off that way any further because it hits the wall. So I'm going to have to flip this around and do it on the back side, which is going to be a challenge, but I'll just edit out all the cursing. I planned this out so these two are on a 12-inch center. So now I just need to edge find the ruler, and that'll give me the edge of the next one. And of course these holes are coming out in the most awkward place possible, so I need to counterbore them. And in order to do that, I need to clearance the bottom of them too. I am happy with how all of those are sitting. I do need to grab some shorter screws for some of these, but I can move on to working on the clamping bar. I went ahead and did one set of these because I can do basically one set in each setup. I'm fairly confident in the distance between these, but I don't have a good way of measuring it very precisely. So what I'm going to do is use some transfer screws. If you're not familiar with these, it's basically just a little hardened point on almost like a set screw. It has a little tool to screw these in. And then I'm just going to attach the ones I've already done. Then give it a couple good whacks with the hammer. And now I've got marks I can pick up where I need my holes. And with the part flipped over, I can use the pilot on the counterbore to locate the holes, and then mill out the notches. Of course, being cold rolled, if you cut big notches in it, the internal stresses come out to play, but that's nothing we can't fix with the arbor press. So I went ahead and drilled and tapped for this extension bar on here, and got everything mounted up, and the hinges are moving nicely now. And that has everything to do with the care I put into machining those and nothing to do with the 5 hours I spent adjusting clearances to get them to move. But getting that to move is going to be a lot easier if I put some handles in it. I made up some legs or feet or whatever you want to call them out of just some C-channel to bolt to the bottom of this thing so I can clamp it down to the table. And yeah, this table is just a piece of plate sitting on top of a tool cart, but don't judge me. Next thing to do is to semi-permanently Loctite these screws in. Hopefully what will be the last piece of this puzzle is the clamping bar. For this I've got a piece of hot rolled flat bar. First thing I want to do is straighten and square up one side of it, which again takes multiple setups. And the last thing to do on this is put a bevel on the working edge. This is one of those things that if I had a Bridgeport with a big table and could tilt the head front and back, it would be pretty easy to do. It became apparent pretty quickly this wasn't the best way to do this. So I made these fixtures. It's one of those things where it takes a lot longer to make the fixtures than to do the actual machining, but I figure these will be useful in the future, so put some time into them. They're pretty well matched. If I find that I use them a lot, I might go back later and grind them in to be a lot closer match, but for what we're doing here, they're definitely good enough. These are drilled and tapped so I can use either size of my clamping hardware on them because I put a little forethought into it. Oh jeez. Sorry. Are you okay in there? I bumped up to a 48 volt power supply. That should give me between 12 and 14 amps going through this. Been playing around with it a bit. Let me show you what I've got going on. So with a small piece like this, it works fine. This is 18 gauge. I think it's 1.2 millimeters. Let's try a longer piece. And now you see the problem. So this clamp bar is not spanning the entire magnets, so I think I need it to be a little wider. And I'm just going to try to... You know, some guys on YouTube make that look really easy. I'm just going to go make a wider one. Okay, let's try this one. So that's definitely better. It's not a real tight bend on it because it did shift back a little bit. Let's try going full length and see what happens. I did also try this with some welding clamps on the ends to help out, and it kind of helps, but still not enough. Well, that is one that I kind of knew was going to happen. Doing the math on the magnets, it's just not powerful enough to do the full length. I think it will do the smaller ones okay because the ends of the bar are in closer contact with the magnets, but it's just not got the strength to do the full length of it, which is obviously pretty disappointing. But I think I have the hard parts done. I have the hinge, the bending bar, the handles. So I think what I want to do is go back and do what I should have done the first time and follow the instructions. I always feel the need to try to reinvent the wheel, but in this case, Alan Bottomley has very detailed instructions on his website on how to calculate the size of the magnet, build the magnet, wind the coil, all of that. I should have done that the first time, but this was worth a shot. It was a neat experiment. I learned a lot, and I think I gained a lot of understanding of how this should work. I think this video is long enough, so I think I'm going to leave it off there, come back to another video on building the new magnet, and showing you why I think this thing is worth all this effort and trouble to go through. So if you want to see that, stick around and consider supporting me on Patreon because I need to buy a lot of magnet wire now. And if you're finding this sometime in the future, I'll leave a link to part 2 right over there. And if it's not up yet, go watch that video anyway.